everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about the effect of temperature on JFET devices. So, there are two primary mechanisms underlying the temperature sensitivity of the conductivity of JFET channel. First one is decrease the depletion region width at the gate PN junction with increase in temperature. So, first, what is telling that if we increase the temperature, the width of the depletion region will decrease. If suppose this is the N-channel JFET and it has some width of depletion region, let's suppose this is the width of depletion region. So due to the effect of temperature, if temperature increase, then this width is decreasing. So now the width will stand little here. So what is happening due to the decrement of this width? What is happening? The channel is narrow here, and after the effect of temperature, the channel is wide. Okay, the wide channel. If channel is wide, it means ID current will flow more. Okay. If channel is wide, what it means? It means ID current will flow more. Okay. So ID will increase due to the effect of temperature in case of first case. So what is happening? Due to the effect of temperature, the width or thickness of this depletion region is decreasing. So if thickness is decreasing, it means the channel is wide. If channel is wide, it means more current will flow towards the channel. Okay. This is the increase in channel thickness. Channel is thick, it means wide. Thin means sharp and wide means thick. Okay, so channel is thick. And the second one is decrease in carrier mobility with increase in temperature. Okay, let's suppose this is a JFET bar and these are charge carriers. In N-channel JFET, these all are electrons. So these has particular mobility. These are traveling here and there. But what is happening due to the effect of temperature? If we apply temperature, this carrier mobility is decrease in carrier mobility with increase in temperature due to the effect of temperature. If temperature increase, this carrier mobility decrease. It means now the charge carrier are dense with each other. The free flowing path between the carrier flow is abrupted. So the charge carrier increasing. If charge carrier increase, it means the mobility will decrease. So if this mobility is decreasing, it means the ID current will decrease now. Okay. So in first case, if ID current is increasing, in second case, the ID current is decreasing. And these two process, first and second, these are happening simultaneously in the FET devices, 1 and 2. So if these two are happening simultaneously, it means it has a balanced ID structure. It means ID will not increase and will not decrease with the effect of temperature. But ID is normally whatever the ID was earlier was the ID now. So one thing we also consider that VGS, which is gate to source voltage. We know that if we increase the VGS to more negative, then the channel will change. So we will consider here that if this case happens, VGS 0, this is balancing. Similarly, if VGS increase, let's suppose if VGS increase, then also these two mechanisms happening and ID is balancing. Okay, the width of the channel is changing, but due to the effect of temperature, the width is changing, but the carrier mobility is decreasing, so that the ID current is balanced. So here in first case, we see that in first case, this phenomena we can see that temperature increase, ID increase. It means resistance has to decrease. So this is negative temperature coefficient. Resistance decreasing, it means negative temperature coefficient phenomena in first case. But in second case, what is happening? Temperature increase, ID decreasing, it means resistance increasing. So this is the positive temperature coefficient of the resistance. So negative and positive temperature coefficient of resistance both working simultaneously here. So we consider FET's defects are zero temperature coefficient devices. Zero temperature coefficient devices. Okay. Zero temperature coefficient. Now I think you know that why it is so much thermally stable and the switching operation of FET is best. And the second one, why it is zero temperature coefficient. Why we call it zero temperature coefficient. Why so? Because the negative and positive temperature coefficient are balancing each other due to the process of first one, the depletion region decreasing, second one, the carrier mobility decreasing. Okay. Now I think the temperature effect on JFET devices is clear now. I will see you in next class. Till then, thank you so much and subscribe.